Good afternoon, everyone. Thank you for joining us for our August Tech Tips Live. This is Phil Mason, and I've got Byron Shetler here with me.
Hi.
So thanks for waiting until about 2 minutes after 2 o'clock. We have the traditional Thursday afternoon tornado siren test here in Goshen. the joys of the Midwest. And it never works too well to get that started. But anyway, today we will be covering the topic of wizards. And, wizards at some level, I think, have gotten a bad name from the old days of Microsoft and some of their attempts at animation. And
You're not hating on Clippy, are you?
Oh, hey, Clippy. Everybody loves Clippy, right? No, I was thinking, they actually had like the little wizard dude.
They did.
That used to go back through that. Well, ours are not quite that visual, but anyway, they definitely do a lot of the heavy lifting. And so I'm going to set the stage here a little bit today and talk a little bit about what it is we're doing with wizards. And just remind, Byron will spend some time going through some scenarios and showing you the steps, some of the ways that using GainSeeker to drill down into data, it can really reveal some of the core issues that are going on. So to start out with, we have situations, and many times we've talked to clients, prospects, and we've heard from engineers a lot of times. Once we've shown them a couple of the wizards, they say, do you realize how much time you're saving me? I used to print out chart after chart. I'd do a whole stack, and I'd go into a big conference room, and I'd lay them all out on the table, and we'd start evaluating and assessing and trying to look at how they might relate. And I just saw you do the same thing with 3 or 4 clicks. And that's a little bit what Byron will show you today, is how we have set up GainSeeker to really do some of that heavy lifting for you. But one of the really important things that we see is that GainSeeker helps users in deciding what are the factors that really do impact the process. And for any of us trying to decide, well, is it the machine? Is it the line? Is it the different shifts? Is it raw materials? Was it just that lot? Figuring out exactly what are those things can be a challenge, and we tend to fall back on gut instincts or some things like that. So, and the other thing I want to point out is we also sometimes have the challenge of, well, if we have a hunch or we see a problem, where is it that we actually start? What path do we want to go down? And sometimes where we start in a traditional sense of analyzing a root cause can really influence what the result is. And one of the great things with some of our wizards is that, again, GainSeeker looks at multiple iterations, looks at where the biggest impacts are, and does some of that heavy lifting for you. Byron, is there anything you want to throw in there?
I think he captured it well.
Okay. So, what happens when we do it the old way? We can end up running down dead ends. Well, I think it's this. And you go down a path, and then it's like, oh, that's not it. Now what do I do? You go back, start over again. And continuing to rely on those hunches and gut feelings, not really going down the path that's supported by the data. And then we have places where typo, corrections may be applied inappropriately, not appropriately, inappropriately. So we go down that wrong path, we go down some hunches, but then we fix something that really isn't the root of the problem. So that can, again, become part of a challenge. So what are we able to do? We're able to let GainSeeker do the heavy lifting, as I mentioned. Wizards then give you some of that proof, that real proof that you need to target where your corrective action is. If somebody doesn't believe you that that's the cause, you have the data, the hard data to back it up. So we're going to spend a few minutes here. Byron's going to run us through some specific examples of how GainSeeker does this, and I am going to pass the presentation over to him and get it going.
All right. You're now the presenter.
Byron's now the presenter.
Okay.
There you go.
Oh, did I accidentally leave up a new feature in 9.3, the data canvas running? Just a little sneak peek for you people to see.
I'm not seeing it yet.
Oh, you're not seeing it?
Are you sure you haven't shared?
Okay. Well, let me click on that again. Here we go. Sharing the screen. Do you see it now?
Yes.
Hey, all right. There I went that time. So I must have accidentally left up a new feature called Data Canvas in 9.3 as showing you numeric inputs with maybe reading from a fixture, some gauges, showing some numbers in on a graphic. So we'll do that and get on with today's presentation.
We'll save that for another month.
Yep. All right. So we have a lot of wizards in GainSeeker, and sometimes I call them like the poor man's artificial intelligence. Without having to get into complicated machine learning and natural language processing, which we now do. We had a previous Tech Tips Live on that. These tools can help you go a long way in identifying sources of variation. And even if you've used these tools in the past, stay tuned, you might learn a new thing or two. As I was prepping for this Tech Tips Live, I ran across a couple of things that I had forgotten were in the system. So even I learned something or remembered something from the past. So
It's why we do these things.
Now, hopefully, many of you are already familiar with the group data functionality of GainSeeker system. There's a lot of power in just simple grouping, where you might be looking at a data set, go in and regroup it by machine. So you can see there's 1, 2, 3, 4 different machines there, segmented, grouped by, what's another one? By shift, maybe. Or by operator. There you can see that the shifts are behaving slightly different. The mean on shift 3 is a lot higher than shift 1 and 2. So rather than doing all this work manually, though, where you've got a lot of traceability and you're wondering where are my sources of variation, where are they coming from, let the computer do the heavy lifting for you. So if I go back in and turn my grouping off and just get my chart, there's my chart with my data. At this point, I'm going to right-click and start the variation wizard. And you want to make sure you're running a stable process. If you look at the stability information here, I've got 2 values that are outside of control limits, and we didn't do any identification of runs, trends, or zones. You want to make sure you have a stable process before you get into this. But once you've got a stable process, you can go in and decide which traceability you want to look at in terms of drilling down and grouping the data. I've got them all checked at this point. And I'm going to start with a minimum of 10 items within each group to be considered. And I'm going to start at the simplest level, level 1, in terms of the grouping. So what happens when I click the next button is the computer will go through and do all those manual, in essence, do all those manual group data that I was going to do myself, does them all for me, and comes up with the traceabilities and ranks them. Now, you see the lot number disappeared, and my lot numbers are changing frequently, so there weren't enough to have 10 in a group, so that's why that one disappeared. And if I hover over shift or operator, you can see my F and T test values. If the values aren't at least 95%, then I know there's probably not a significant difference between either the spread or the mean in terms of the different groups and different data sets. So shift seems to be my number 1 item in the list here. So if I click chart, it goes out and groups data by shift. And as I had mentioned before, that mean on shift 3 really seems different than the means, which are pretty close on shift 1 and shift 2. Those means are relatively close. You also see the spread on shift 1 is pretty tight compared to 2 and 3. So the variation wizard, if I go back into it, will go through, especially if you have a lot of traceability, really go through and simplify your work for you to show you where your sources of variation are coming from. Now, one other thing I could do, let's say I can look at machine group. It's not real exciting there. Everything seems to be pretty uniform across. But if I would go in and say new charts for groups and pick that first group here and draw a new chart for just that machine, and I happen to know, because I ran the wizard earlier, you know, that again shift 3 for that particular machine is behaving very differently. This information of those different shift parameters is kind of hidden back at the machine level. But if we go back to the beginning, the very beginning, and look at the interaction, so I'm going to resume that initial wizard and go back a step and look at interactions. Basically, this will go through and do what I just did. It'll take like a machine as an example and run through all the other traceability and split it up among those other traceability for each machine. And then for each shift, it'll do the same thing. It'll take shift 1, run through all the permutations, shift 2, all the permutations. So when I change it to level 2 interaction, it's going to do a lot more work. And here, as you saw what I just did manually, that machine 2370B, when you group it by shift, has a pretty significant difference in terms of both the spread and the mean. And you can see here that it splits out all the various traceability values. So again, this gives you a clue if you're doing cavities, maybe a left and right cavity. Again, and we chart that, you can see here that, again, by shift, that third shift, they're just doing something different.
They're all sleepy. They're really sleepy.
You know, and this might be a place where prescriptive analytics come in the future, where system will make recommendations on what you could do to decrease variation.
So first level, it's going through, it's looking at our top level of traceability. F&T test, what's significant, telling us what's significant. You go to that second level, and now it's really combining those of, okay, what's significant, but are there traceabilities that together now form significance and take it to a whole nother level?
Yeah, like that machine, there wasn't really anything going on there between machines, but when you break it down, like that first machine by shift had some definite differences going on.
Excellent. So even just on that second level, I forget exactly what the whole list was, but we had like 20 different items on there that, just like my first example, you could have somebody printing out 20 different charts and trying to compare all those on the big conference table. Boom, it's right there. Yeah,
it really simplifies things. So let's jump straight into the variation wizard on this data set. And in this particular case, you'll notice that I've got a temperature traceability, and it's set to continuous instead of discrete data. So what happened here is we actually recorded a process parameter, the temperature, while we were collecting measurement data. And so if we go to this next screen, you'd see now we have 2 lists, and there's nothing exciting on the top. There's really nothing going on there in terms of significant differences for the traceability, but you see a pretty high correlation where +1 would be a direct correlation, an actual direct correlation that varies from -1 to +1. But here, 0.776 is pretty high. So if I would do a scatter plot of that, you can see as my temperature increases, my average measurements are increasing as well. So there's something going on with that process, whereas the temperature, maybe a room temperature, well, not in this case, it wouldn't be room temperature, you'd be boiling. But an oven temperature, as that increases, your dimensional values are increasing as well. And that's just taking some value stored in traceability and comparing it to the measurement data. Now, if we switch over to the defect side of things, let me pull up another desktop here. This is plotting Pareto's by process. And if I double click on that top bar and drill down by machine, I see my 3 machines, and this 1057 seems to be an issue. It's got a big bar there. So I can drill down on that in terms of part number. And my connector part seems to be the biggest one. And I'll drill on that to see, okay, distorted is my biggest defect reason. Now, if I tile those charts, you can see in the bottom right corner, if we kind of follow that back, I had a blue chart and I double-clicked on the top bar, it turned red, and then I had a red chart, I double-clicked on the top bar, it turned green, then I got a green chart, double-click top bar. What color is that?
Cyan? I don't know. Mustard. It's mustard.
There you go. Mustard. I double-clicked on that bar and I got the mustard chart, which is the defect. So the colors kind of give you a clue as to what sequence you followed as you went through that. And it's showing me that, sure, that the distorted was the biggest. So another way to do that, instead of doing all this drill down again, is to start the drill down wizard. And here I'm going to pick to include all the data, not just the biggest bars, but everything. And any bar that's less than like 20% of the data, I'm going to exclude. Now you could slide that down to smaller percentages to include more things. But when I hit next, what the system just did is it ran through every Pareto drill down possible, and it said, all right, what are my biggest bars out there? So for shift, 62% of my defects are happening on shift 1. And department, the technical and printing, those two are pretty high, basically 40 and 30%. So it's going out and just finding the biggest bars out there. Where are your biggest defects coming from? And if I want to explore a little further, let's say I want to explore where shift 1 defects are coming from. I had forgotten this was in here. There's a drill down button right next to the next. So
there you go.
Or I can hit next, and that will actually drill down into shift 1. So for just shift 1, it did all the Paretos again. That was like I just drilled down into shift 1, and it ran through all the Pareto bars for me again and found which were the biggest bars. If I go back, I could accomplish the same thing by clicking the drill down button here and run through various ones. But again, let the computer do the work. I'm lazy. Let the computer do all the work, and it will go through and analyze all the biggest bars for shift 1. So that's a pretty convenient way to figure out where your biggest sources of defects are coming from in that case. So one other thing.
So we have a question from the audience wondering about, and I think this is, I was thinking this is where you're going, Byron, is, okay, we got this now, but what about cost? How does cost factor into this?
Exactly where I was going. So if we duplicate this and look at costs, you can see in the original Pareto, molding was number 1 at the top, where if you're looking at cost, about 5th or 6th down the list. So at this point, the wizard is really only looking at defects. It doesn't take cost into account, but that's a future enhancement, is to run through the wizard with the costing values and to pull those out so that you can do the same thing with cost. And again, those costs can either come, as you set up the defect reasons, you can enter costs in then. You can pull in costs from ERP systems. I know we have a couple people pulling in defect costs from their ERP system, like what did the raw materials cost to make, and actually one company's pulling in labor rates, so they're also tying in to their cost value dynamically from the ERP system, how many people were working on that line or machine, what were their labor rates, and then that goes into the cost calculation. So it's dynamically figuring out what the cost of that defect was. You've got a part that has a long cycle time, takes a while to make, complicated process. They want to know, what does it really cost to generate that defect, not just raw materials.
And if you're somebody doing the analysis, you don't necessarily have to know the cost of all these things. I mean, you could be looking at it and say, oh, well, here's the biggest Pareto for defects and want to go after that one, when in reality, no, if I flip it and look at the costs, the people upstairs may be more interested in,
much more
yeah, but
interested
what's
in
costing us?
in fewer count defects, but higher cost.
Yeah.
So
Excellent.
you can even take, so we went from group data to the wizards. You can even take that higher to another level with a dashboard big data widget. So this particular one I have set up to look at this whole family of this 2-904 family of parts, all the features, all the characteristics of that part. And here, what this widget did is it did all of our variation wizard results, and then it aggregated all those in here. So you could have this widget running in the background. It did the continuous on the right and the discrete on the left, but you could have this widget running in the background, and it will bubble up stuff throughout the day. You can even scan your entire database. So, you know, if I would go in here, look at my properties of this widget, and turn my filter off where I want to look at all data instead of just that one particular family of parts. And here you can see, like, you can change the colors that show up to say if the mean's out or the spread is out. So if I go back in here, now it's running through my entire data set. I'll go ahead and cancel it so it doesn't just keep running. But you can see there's color coding in terms of what's going on, and that's for all parts that I have in the system, all features, all characteristics that I have in the system. So you can have this running in the background on a timer, refreshing every so often, and it'll bubble up your issues to the top. And you can do the same thing with the DMS as well, DMS system. So again, the drill down wizard. I'll go ahead and cancel that, and then you get different color coding on that as well. And with all of these, you can right-click, draw charts, look at the data, do all of that just like on the SPC. You can either look at the continuous data, the discrete data, draw charts on that information. So pretty powerful.
So powerful tool for people who are maybe not necessarily even on the shop floor. They can have this, pull it up, at a glance, see what's going on, right-click, get to the charts, you know, send it out to something else they want to do some further analysis, look at the raw data, all kinds of things like that. All right, well, it's 24 after, so if we have some questions, we will entertain those, or I didn't necessarily mean to cut you off either, Byron.
No, that's fine.
Anything else you want to say? But if we have some questions, feel free to, in the Q&A box, ask us, type those in there, and we'll get them to Byron.
While we're waiting on questions, we showed this defect trend wizard, which is new in 9. A couple months ago, here I have it comparing current year shift 1 versus current year shift 2, using shift 1 as a baseline. You can see shift 2 is generating 25 more defects than, that's what that change from the baseline is, 25 more defects. And I can click on there and say, oh, they're also generating a lot less package broken defects, 157 less shift 2 is than the baseline shift 1. So this is what we call a defect trend wizard, and you can do it by percentages too, but it'll show you, are my defects trending up or down compared to a baseline for whatever time you're looking at?
Right, and this came from a client who was using this on looking at warranty reasons, and they wanted to see, while they tended to know what some of their big warranty reasons were, they wanted to see what was bubbling under the surface. And so they were wanting to see what those changes over periods were, that maybe were down in the 12 or 15, you know, lower down in the Pareto and moved from 12 to 8, but maybe in the percentages didn't attract that much attention. They wanted to see, well, have we got something coming, right, that we might want to know about.
And if we've got any food customers out there, there's also if you have a histogram up, there's also what we call an overpack wizard. And, you know, one thing it tells you is if you optimize or shift your process, in this case, you just need to move the mean over, if you're making snickerdoodle, 4-ounce snickerdoodle packages, and you're making X amount of packages a month, if you know the cost per unit, you could save over $5,000 a month on that one type of product just by shifting your mean over. And you can even get fancy with the wizard and say, what if I reduce my variation 25% plus shift the mean? So if I do that, it generates a new data set for me. Now when I go into the wizard, still assuming I'm going to shift the mean a little bit, in this case, you know, I can save $16,000 a month on that one particular product just by tightening my variation and then shifting the mean.
Yep.
So it's pretty powerful, quick and easy. We're going to make some enhancements to this particular wizard in the future as we do some more foods enhancements. But the idea there is to help you out. You don't have to sit down with Excel and generate spreadsheets and do all this in your head. We'll do a lot of that heavy lifting for you, which is the whole thing behind the wizard. Let us do the work. Let the computer do the work for you.
Let us do the work. So a couple of the keys, what I've heard you say too, Byron, is obviously you need to be collecting some traceability, because you know that is a part of it. Where is the variation coming from? And have that traceability out there. So that's really an important part of it. And then you can go obviously over large ranges of data. We were looking at fairly small ones here, but you can go.
You can scan your entire data set, yeah.
Awesome. Fantastic. All right, one last call for questions out there. We've got a couple more minutes. Also want to say that if anyone has suggestions for other Tech Tips Live, please email those to me or put them here in the questions area as well. You can email me, phil@hertzler.com. We're having a meeting tomorrow afternoon, in fact, to plot out our Tech Tips Live for the remaining part of this year for September, October, November. We want to get our topics on the calendar and get those out to you. So we definitely appreciate all of you joining us today. Thank you, Byron, for the demonstration.
You're welcome.
And showing us how GainSeeker can do some of the heavy lifting. Oh, I got one here. Can the defect trend wizard generate a run chart?
Not at this point. Interesting idea, though, yeah. I think we could maybe scrape. So you can draw line charts through the Python interface, through dashboards. Possibly scrape that data, use Python, and like use a Google Charts as well, or the built-in line charts that we have for Python, and then do a run chart. It might make more sense to do like a monthly defect average or defect count for each defect, and then do a run chart by month, which you can already do in the system, like a DPU chart would do that for you.
Okay.
But it wouldn't have the trending information, but I like that idea of grabbing that trending information to see how it's going up or down and plotting that.
Excellent. All right. Well, thanks for that question. And if you have follow-up on that question or want to give us a little bit more context, you can get Byron at Hertzler.com, or myself, Phil at Hertzler.com. You can get either of us. All right. Well, that, I think, wraps her up for today. So thank you all for joining us, and we look forward to seeing you all at another Tech Tips Live.
See you next time.